Okay, I want to talk a little bit about how the flexural strength, how the behavior is in a pre-stressed beam that's a little bit different than what we had for reinforced concrete. So let's just talk ourselves through a load P versus deflection curve. So assuming that the beam is loaded up, it could be uniform load, but we're using a point load of P at this point. And typically in concrete we would start at the 0, 0 place because we'd have zero deflection and zero load. But in pre-stressed concrete we actually start back here at a negative deflection, also known as the camber. And as we load the beam up, so this would be the camber where you have the deflection, and the self-weight would be contained within there. You could plot that as well, but let's say this is 0.0, so your transferred case, and then we load up with any extra additional applied dead load. So let's say that takes us to here. Typically they'll want that to be still a little bit of camber or right at 0. And then let's say we then go ahead and load up with full live load. So this would be our delta due to camber. Okay, so we started a negative delta, and then if this is dead load, this would be delta due to dead load. And we could also take a look at delta due to live load. Now you'll notice, as much as I could draw here, that this is basically a straight line. This total delta, additional delta due to live load, sorry, this would be total here, where you have all the dead load and all the live load. So we had an additional live load that took us to here. So this is at our service calculation. This is at transfer. This is after some of the load is applied. And what will happen here, and I probably should have made this curve a little steeper, but you'll continue on a nice linear path because it's uncracked. So that whole time it's uncracked. At some point, if you take this up to ultimate, you're going to start to get the curving over. So this line looks a little bit different because we don't get cracking for quite a while, and we're uncracked at service. So in pre-stress, until you start getting this nonlinear behavior, you're actually uncracked, and here is where you start the cracked behavior. And the reason it's softening, of course, is because you're developing cracks in the system. So unlike in concrete, where we hit that cracked portion before service, in pre-stress concrete we go ahead and have a linear p-delta relationship, even if it starts at negative delta, for the entire service portion of the beam. So now we're going to be looking more over here at ultimate capacity. So this is a safety portion. It's not necessarily failure, and then a beam would be failure, but this is our ultimate capacity, and that's the same, a little bit different procedure, but generally the same as what we did for reinforced concrete. And so that's what we're going to be learning in this section.